Imagine the sun, this big warm ball of nuclear soup that makes your morning coffee possible, suddenly turning into a cosmic murder machine. You would not even have time to say goodbye to your Wi-Fi router. Out there in the universe is an entire category of stars that could erase Earth in less time than it takes you to type an angry comment online. We are talking about gamma-ray burst stars, specifically massive Wolf-Rayet stars, or collapsing hypergiants, that are basically ticking space bombs, waiting to detonate with the energy of billions of suns. And here is the charming part. They do not need to physically hit us. They can just point their cosmic death beam our way and strip our atmosphere like peeling a banana. The top candidate in our neighborhood is a lovely star called WR104, sitting about 7,500 light-years away. That sounds comfortably far, but in cosmic terms, it is like living a few blocks from a lunatic with a flamethrower. WR104 is a Wolf-Rayet star, meaning it is shedding mass faster than you lose motivation at the gym. It is a star on steroids, burning through its fuel so violently that its death is not a question of if, but when. When it collapses, it could launch a gamma-ray burst directly at us. And if we happen to be in the line of fire, Earth is done. No evacuation plan, no doomsday bunker, not even Elon Musk's rocket toys will help. A gamma-ray burst is not a gentle sprinkle of cosmic light. It is a focused jet of high-energy radiation that would obliterate our ozone layer in seconds. The ozone layer is that fragile shield that keeps us from being microwaved by ultraviolet radiation. Without it, every living thing on the surface would get a sunburn that makes tanning beds look like spa treatments. Plants would die, ecosystems would collapse, and the food chain would unravel faster than a cheap sweater. The last time Earth may have been hit by something like this, about 450 million years ago, we had a mass extinction event. Coincidence? Probably not. What makes WR104 scary is that scientists are not entirely sure if its axis is pointing at us. If it is, we are staring down the barrel of a cosmic shotgun. If it is not, then we get to live another day worrying about mundane things like taxes and whether pineapple belongs on pizza. It is the uncertainty that adds the spice. We know it will explode, we know it will be catastrophic, but we do not know if we are in its sights. It is like having a neighbor who is definitely going to throw a grenade one day, and you cannot tell if it will land in your yard or someone else's. Gamma-ray bursts are the universe's version of flexing. A typical burst releases more energy in a few seconds than our sun will produce in its entire 10 billion year lifetime. If one were aimed at us, the burst would erase Earth's biosphere almost instantly. The only organisms likely to survive would be deep ocean bacteria, the tough little weirdos that do not care about sunlight or radiation. Humanity, with its fragile Wi-Fi signals and expensive sunglasses, would be gone before you even had the chance to finish watching a video about it. And here is a fun twist. Even if WR104 exploded right now, we would not know until 7,500 years later. That is the cruel humor of space. The light and radiation take that long to travel, so the star could already be gone, its deadly beam already on the way, and we are just sitting here, casually scrolling through memes. Every sunrise you see might already be your last few thousand. It is like playing Russian roulette with the universe, but you do not even know someone handed you the gun. But WR104 is not the only suspect. Our galaxy has plenty of unstable stars ready to blow. Eta Carinae, a massive star system about 7,500 light-years away, is another contender. Eta Carinae is a stellar drama queen, having already erupted in the 19th century in what astronomers called the Great Eruption. It is like a celebrity that cannot stop making headlines for bad behavior. When Eta Carinae finally dies, it will likely go supernova in a spectacular fashion, and there is a chance it could deliver a nasty dose of radiation. Thankfully, astronomers believe its orientation is not aimed directly at us, so we can keep worrying about smaller problems like our electric bills. To appreciate how catastrophic a gamma ray burst would be, let us look at what it actually does. First, the radiation strips the atmosphere of its protective layers, allowing solar and cosmic radiation to slam directly into Earth's surface. This triggers chemical reactions that produce nitrogen oxides, which are toxic compounds that would spread globally. Imagine acid rain, but with a side of lung damage. Meanwhile, the sudden influx of radiation would heat the upper atmosphere, destabilizing climate systems. Oceans would acidify, food chains would collapse, and the planet would spiral into chaos. In other words, it would be less of a Michael Bay explosion and more of a slow, global suffocation. Scientists have speculated that a gamma-ray burst may have triggered the Ordovician mass extinction around 450 million years ago. At that time, about 85% of species on Earth were wiped out, and the sudden spike in ultraviolet damage lines up suspiciously with what a gamma-ray burst would do. It is cosmic circumstantial evidence, but it fits. The idea that life's biggest wipeouts may have been caused not by asteroids, but by a star tantrum adds a nice poetic cruelty to the story of evolution. Now, before you panic and start Googling how to build a radiation-proof bunker, keep in mind the odds. The universe is vast, and even though gamma-ray bursts are terrifying, the chances of one being aimed directly at Earth in our lifetimes are extremely small. We are talking lottery ticket odds, but with the prize being extinction. WR-104 might not be aimed at us, and even if it is, the event could happen tomorrow or millions of years from now. The uncertainty is maddening, but the probability is mercifully tiny. Still, it is hard not to feel slightly insulted that the universe even built such a weapon in the first place. You might wonder why stars even bother with gamma-ray bursts. The short version is that massive stars burn through their fuel too quickly, and when they collapse, all that energy has to go somewhere. In some cases, it channels into twin beams of gamma radiation, shooting from the poles of the star. It is nature's way of venting. If you were a giant, unstable ball of plasma collapsing under your own weight, you would probably want to scream too. The difference is, your scream would not fry entire planets across the galaxy. So what would humans do if a gamma-ray burst was inbound? The answer is, not much. With only seconds of warning, there is no defense. We cannot deflect radiation. We cannot shield an entire planet in that time frame. Maybe a few people living in deep underground bunkers or submarines might ride it out, but civilization as we know it would not survive. The dream of interstellar escape also fails here, because even if you had a fleet of rockets ready, you cannot outrun a beam of light. This is one of those scenarios where the only real option is acceptance. The universe sometimes just wins. The bizarre comfort is that gamma-ray bursts remind us how fragile we are. For all our technology and hubris, we are still tiny organisms clinging to a rock, entirely dependent on a thin layer of atmosphere. One unlucky star tantrum, and we are gone. It puts things in perspective. The arguments we have over reality TV or the flavor of potato chips feel a little less urgent when you realize the cosmos could delete us without even noticing. The universe is not out to get us, but it also does not care if we are in the way. So the star that could annihilate Earth in seconds is not a villain with intent, but a byproduct of physics. WR-104 might be that ticking bomb, or it might not. Other stars could follow. The galaxy is full of possibilities, and most of them do not care about your plans for the weekend. That indifference is both terrifying and oddly liberating. We may be fragile, but we are here now, sipping coffee, worrying about trivial things, while somewhere out there, a star sharpens its cosmic blade. If that does not give you a sense of both humility and absurdity, nothing will. If WR-104 decides to end its stellar career with a gamma-ray burst pointed our way, it would not even feel personal. We are just collateral damage in its last act of violence. Imagine a celebrity meltdown that is so dramatic it takes out an entire continent. That is what we are dealing with, except the celebrity is a giant unstable star, and the continent is the planet. The scary part is the speed. Light travels at, well, the speed of light. So once that burst leaves the star, we cannot dodge it, bargain with it, or even complain about it on Twitter. We are done, and the only record left would be fossils of cockroaches, wondering why their snacks are glowing in the dark. The reason gamma-ray bursts are so energetic comes down to physics on steroids. When a massive star runs out of fuel, its core collapses into a black hole or neutron star. That collapse funnels matter into swirling jets, and those jets get focused into beams so narrow and intense, they make nuclear weapons look like firecrackers. These beams are what we call gamma-ray bursts. They are the closest thing the universe has to a death laser, except instead of being invented by some cartoon villain, they just happen whenever a star gets tired of existing. It is like a retirement plan with unnecessary violence. But here is the thing. Stars like WR1.04 are rare. Wolf Rayet stars are the drama queens of the stellar world, and there are only a few hundred known in our galaxy. Not all of them will produce gamma-ray bursts, and not all of those will be aimed at Earth. The odds stack in our favor, though the possibility lingers like an unpaid parking ticket you keep ignoring. The longer we survive, the more we gamble. One day, the cosmic dice might not roll our way. Some researchers argue that gamma-ray bursts are one reason advanced civilizations might be rare. If bursts sweep through galaxies every so often, they could reset the clock on biological evolution. Complex life might arise, flourish, then get fried over and over. From this angle, Earth surviving long enough to produce humans might be less about destiny and more about sheer luck. We are like someone who stumbled out of a minefield and thinks they are a skilled walker. In reality, we just did not step on the wrong spot yet. The atmosphere damage would not just be ozone loss. A burst would inject so much energy into the atmosphere that nitrogen molecules split apart and recombine into nitrogen dioxide, a reddish-brown gas that absorbs sunlight. That could plunge the planet into darkness and trigger a sudden global cooling, like a nuclear winter without the fun of politicians to blame. Crops would fail, food chains would snap, and within months the survivors, if any, would be wondering why their apocalypse feels less cinematic and more like slow starvation. The irony is that we fear asteroids because at least you can see a rock coming. Gamma-ray bursts just turn off the lights. Now, before you lose faith in the cosmos entirely, remember that the universe is mostly indifferent, not malicious. Stars explode because of physics, not because they hate us. The sun will die in about 5 billion years, but it will not produce a gamma-ray burst, so we are safe from that, at least. Most stars nearby are not lined up to murder us either. It is only the rare monsters like WR104 and Idkbro that keep astronomers awake at night. Even then, they keep reminding us that the odds are low. Think of it like shark attacks. Yes, it can happen, but you are more likely to drown in a kiddie pool than get bitten. Still, the possibility is enough to keep the mind entertained. What makes this entire subject so irresistibly fascinating is the contrast. On one hand, humanity builds particle accelerators, smartphones, and overpriced coffee machines. On the other hand, a star thousands of light years away could sneeze and erase us without warning. It is like building a sandcastle while a tsunami brews offshore. We might feel proud of our architecture, but the ocean does not care. The fragility makes our little projects feel both absurd and oddly precious. Maybe that is why people love space disasters in fiction. They remind us that we are temporary guests at a very unstable party. The philosophical kicker here is that Gamma ray bursts are probably one of the reasons you are alive to worry about them. By wiping out competitors in the evolutionary past, they may have paved the way for mammals to rise. In other words, cosmic genocide might be the only reason you get to sip coffee today. Life's history is shaped not just by survival, but by lucky near misses. We are descendants of the survivors of mass extinctions, beneficiaries of chance in a universe that plays dice with stars. So, is WR-104 the star that could annihilate Earth in seconds? Possibly. But the universe has many such candidates, scattered across the sky, waiting for their final performance. Each one is a reminder that safety is an illusion. We might feel secure under our blue sky, but that sky is one fragile shield away from collapse. Still, the fact we even get to exist long enough to ponder these threats is extraordinary. We may be fragile, but for now, we are here. The universe could erase us at any moment, but until it does, we have the luxury of worrying about far smaller problems, like whether our neighbor's dog is barking again. Maybe the lesson is simple. Do not take the fragility too seriously, because you cannot fix it, and do not take it too lightly, because it is real. Life exists on the knife edge of cosmic accidents, and the fact it persists anyway is almost miraculous. If one day a star decides to scream its final scream in our direction, we will not be around to complain. Until then, enjoy your breakfast, because the sky is quiet, the ozone still works, and WR-104 has not spoken yet. That silence is not guaranteed, which makes it the most valuable thing you own.